Welcome back to UST 107. This week we are covering Chapter 2, National Airspace System. Understanding the National Airspace System objectives, interpret NOTAMs and airspace resources, classify airspace types and their operational roles, recognize topographic influences on flight, navigate airport environments and markings, and apply collision avoidance strategies. The National Airspace System, NAS, is a network of both controlled and uncontrolled airspace, both domestic and oceanic. It also includes air navigation facilities, equipment and services, airports and landing areas, aeronautical charts, information and services, rules and regulations, procedures and technical information, manpower and material. There are two categories of airspace, regulatory and non-regulatory. Regulatory includes Class A, B, C, D, and E airspace, restricted areas, and prohibited areas. Non-regulatory includes Class G airspace, military operation areas, warning areas, alert areas, and controlled firing areas. Class A, B, C, D, and E areas are referred to as controlled airspace. Class G airspace is referred to as uncontrolled airspace. Air traffic control has the authority in controlled airspace, but not in uncontrolled airspace. The chart supplement US contains information about airports and heliports open to the public. You can refer to this to determine what kind of airspace, ATC facilities, and traffic to expect around the airports near your operations. Aeronautical maps, sectional aeronautical chart, and terminal area chart is what you will mostly be seeing. The sectional aeronautical chart is a scale of 1 inch equals 6.86 nautical miles, designed for visual navigation of slow speed aircraft in visual conditions, which is VFR. Terminal area chart, scale of 1 inch equals 3.43 nautical miles, display a specific city within Class B airspace. NOTAMs, notices to air missions. NOTAMs provide the most current and time-critical information available on airports and changes that affect the National Airspace System. The remote PIC must check for NOTAMs before each flight to determine if any airspace restrictions apply to you. NOTAMs can be found by visiting FAA.gov or from the FAA's flight service by referencing 1800wxbrief.com. NOTAM information is classified into 5 categories. NOTAM D, or distant, flight data center NOTAMs, pointer NOTAMs, special activity airspace NOTAMs, and military NOTAMs. NOTAM Ds are transmitted with hourly weather reports and are available at flight service stations. FTC NOTAMs contain regulatory information, including temporary flight restrictions, and are issued by the National Flight Data Center. Pointer NOTAMs point out another NOTAM, such as an issue of an FTC or NOTAM D, and help in cross-referencing information that may not be found under an airport or NavAid identifier. Military NOTAMs pertain to U.S. Air Force, Army, Navy, and Marine NavAids, airports that are part of the National Airspace System. SAA NOTAMs are issued when special activity airspace will be active outside the published schedule times and when required by published schedule. An FTC NOTAM will be issued to designate a temporary flight restriction, or TFR, and will begin with the phrase flight restrictions, followed by the temporary restriction, effective time period, area defined in statute miles, and altitudes affected. The NOTAM will also contain the FAA coordination facility and telephone number, the reason for the restriction, and all information deemed appropriate. Common TFRs that relate to SUAS operations include presidential TFRs and NOTAMs, emergency response TFRs and NOTAMs, and standing TFRs that go into and out of effect. This is a diagram that shows the different altitudes of airspace. It's helpful to be able to reference this. So feel free to pause the video and go back to look at this through the next bit of slides if you need to. Airspace classification. An SUS operation may occur in uncontrolled airspace, Class G airspace, without permission or authorization. You may not operate an SUAS in controlled airspace unless you have prior authorization from air traffic control. The FAA has the authority to approve or deny aircraft operations based on traffic density, controller workload, communication issues, or any type of operation that may impact the flow of air traffic. This is in your book, but I wanted to put it on the slide too. This is a legend for your sectional aeronautical chart. You will be referencing this quite a bit. There's a lot to look at on these charts, and it can get confusing, so this is very helpful. Controlled airspace is airspace within which some or all aircraft may be subject to air traffic control, which includes Class A, B, C, D, and E airspace. Class A airspace extends from 18,000 feet mean sea level, or MSL, up to and including flight level 600, or 60,000 feet, and is not depicted on VFR sectional charts. No flight under VFR is authorized in Class A airspace. Much of the controlled airspace begins at either 700 or 1,200 feet above ground level. The lateral limits and floors of Class E airspace of 700 feet are defined by magenta shading on the sectional chart, while the lateral limits and floors of 1,200 feet are defined by blue shading on the sectional chart if it abuts uncontrolled airspace. Floors other than 700 or 1,200 feet are indicated by a number indicating the floor. Class B airspace extends from the surface or higher specified altitudes and is centered around one or more primary, which is very busy, airports. Class B airspace varies in size, altitudes, and layouts from one site to another. Class B airspace is outlined in blue on the sectional chart and labeled with delimiting arcs, radials, and altitudes. Within each segment, the floor and ceiling are denoted by one number over a second number, or letters SFC surface. Class B airspace is also depicted on the terminal area chart and is also outlined in blue and labeled with the delimiting arcs, radials, and altitudes. ATC clearance is required prior to operating within Class B airspace, and the pilot must hold at least a private pilot certificate. I included some examples down here of Class B airspace. So the airspace tends to go from magenta to blue, back to magenta. Class C airspace is a type of controlled airspace around moderately busy airports. It's designed to safely manage traffic near airports that have radar approach control and a control tower but aren't as busy as Class B airports. Class C airspace typically has a two-layered upside-down wedding cake structure. Inner core and outer shelf. The inner is going to be 5 nautical miles, vertical range up to 4,000 feet above airport elevation, and The radius for the outer shell is 10 nautical miles, vertical range of 1,200 feet above ground level, up to 4,000 feet above ground level. These dimensions can vary slightly depending on local terrain and traffic needs. On aeronautical charts, Class C airspace is depicted by solid magenta lines. To enter Class C airspace, pilots must establish two-way radio communication with ATC before entry. Have a Mode C transponder altitude reporting if flying above the airspace or within 10 nautical miles of the airport. So this looks a lot like Class B, except it's magenta. And you can tell more so on the left, the wedding cake structure above Lexington. You can on the other two, but I feel like more over Lexington than Louisville. Class D airspace surrounds smaller towered airports, those with an operating control tower, but less traffic than Class C or B airports. It's still controlled airspace, meaning air traffic control services are provided, but with more limited scope. Class D airspace is typically a cylinder centered on the airport, radius of 4 nautical miles, vertical range from the surface up to 2,500 feet above ground level. Unlike Class C, Class D usually has only one layer. However, the exact shape can vary due to terrain, airspace conflicts, or local procedures. It is depicted on the sectional charts by a blue dashed line and numbers showing at the top of airspace, at the top or airspace ceiling. Class E airspace is controlled airspace that supports IFR operations without requiring ATC contact for VFR pilots. Class E is the most widespread controlled airspace in the US and begins where Class G ends, which is 1,200 feet above ground level in rural I struggle with that word, rural or en route areas, 700 feet above ground level near airports with published instrument approaches, surface level at some non-towered airports with full IFR procedures, extends up to 17,999 feet, mean sea level, just below Class A airspace. On aeronautical charts, Class E is unmarked when starting at 1,200 feet above ground level, is depicted with magenta shading when starting at 700 feet above ground level. Shaded side indicates Class E. It's depicted with a solid magenta line when starting at the surface and resembles Class D-C boundaries but without tower symbol. Class G airspace is uncontrolled airspace where the ATC doesn't have authority or responsibility. Class G airspace starts at the surface and extends up to 700 feet above ground level near airports with Class E transition zones, 1,200 feet in rural areas where Class E begins at the altitude, or at that altitude. In mountainous terrain, Class G can extend higher. Prohibited airspace is airspace where no aircraft may enter, like the airspace around the White House and U.S. Capitol building. Restricted airspace is airspace where flights are restricted due to hazards to aircraft. Warning areas contain the same hazards as prohibited and restricted, but are located in international airspace. Alert areas contain heavy training traffic or unusual aerial activities. Military operation areas, or MOAs, is airspace separating military training activities from IFR traffic. Pilots should contact the controlling agency for traffic advisories before entering active MOA. Military training routes are routes used by the military for conducting low altitude, high-speed training that are generally below 10,000 feet mean sea level for operations at speeds higher than 250 knots. Topography is the study and mapping of Earth's surface features, both natural and man-made. It describes the shape, elevation, and relief of terrain. Topographic maps can use contour lines to show elevation changes and landform steepness, essential for navigation, planning, and environmental analysis, and a great tool for drone ops and terrain modeling. Meridians of longitude. Meridians are imaginary vertical lines running from the North Pole to the South Pole. They measure east to west positions on Earth, expressed in degrees from the prime meridian in Greenwich, England. Meridians converge at the poles and are spaced evenly in degrees of longitude, used to define time zones, navigation routes, and global positioning. Parallels of latitude. Parallels are horizontal lines that run parallel to the equator. They measure north-south position, expressed in degrees from the equator. Parallels are concentric circles that shrink towards the poles. Key parallels include the Tropic of Cancer, Tropic of Capricorn, and Arctic-Antarctic circles. Sectional charts use a geographic coordinate grid based on these lines. Meridians, longitude, run north to south and converge at the poles. Parallels, latitude, run east to west and remain equidistant. Each chart is labeled with degrees of latitude and longitude along the edges. These coordinates allow pilots and drone operators to pinpoint exact locations, plan waypoints and flight paths, and reference NOTAMs and airspace boundaries accurately. Each degree is divided into 60 minutes. Each minute is further divided into 60 seconds. This system allows for precise pinpointing of any location on Earth. Let's say a location is listed at 38 degrees, 2 minutes, 30 seconds north of the equator. It would look like that first line in the second paragraph. By 84 degrees, 30 minutes, 15 seconds west of the prime meridian. This describes a point in Lexington, Kentucky, with precision down to 30 meters. So that's all for this video. We will come back and start with airport operations.